Okay, so 1 minute. I will just open the link which we are going to be used now. Okay, I'm sharing the screen. So as we have prepared the metadata line yesterday, metadata file yesterday. So basically, once we have created this, now we are going to import our data inside the Quine. Okay. So I will just open the script. Yeah. So in the script, every command is there. You just have to understand it. Okay. So you can see here the data importing command we are having. So to import the data, we are using this option Quime tools import. Okay. Then hyphen type. So what type of data we are going to use over here? So basically it's a sample data. Like we are having a sample data. It's a paired and sequence data with the quality. With the quality means what? As of now, we are using the FASTQ files. So basically with the FASTQ files, we are having all the quality information as well. That is why this is what a by default option we are giving here. Input path. So in the input path, we have to give the metadata txt. That is our input file. Then output file, output path. Here we are giving this file name patent.demux.qza. So you have to understand one thing, that whenever a Quime is giving us the output, so this output is always in a QZA file format, which is nothing but the Quime to artifact format. So this is what the Quime to artifact QZA. After that, input format. So what kind of input format we are having? We are having a paired and FASTQ sequence manifest Fred 33. 33 is a what? It's a ASCII base version number. You can see over here there are three options we are having: single end with 64, paired end with 33, and paired end with a 64. So whatever like a ASCII base you are having, like either the 33 or with the 64, so accordingly you have to give here the option. So 33 means what? In this variant FASTQ manifest format, there must be a forward and reverse read files for each sample ID, like because this is a parent sequence. And this format, it assumes that Fred offset, which is used in a positional quality score, means this file is 33. So here the base ASCII base is 33, and that's why we are giving this option. And this is what a command we are having for the importing. But first of all, before importing the command, you just have to open your you just have to open your terminal from the metagenomics folder. Then you have to activate the Quime. So to activate the Quime, you have to use this command conda activate, and whatever your version number for the Quime, that you have to use. Enter. Yeah. So you can see right now my quorum environment is activated, and then I'm just going to use this command. I'm just going to copy this command and run it. So this command, it will take some time, more than 10 minutes sometimes. So you just have to wait till it is completed. Okay. Is there any doubt here?
Ma'am, could you please once again explain this command? I just made few minutes.
We have to just import this data, our data in the QIEM. So basically, we
Uh-huh.
just have to activate the QIEM environment, whatever your environment it is. Then QIEMs tool import, we are importing the data. Hyphen type, as we are using the sample data, paired and sequence with the quality. So this is the by default type because we are using the paired and sequence. Input path is your metadata file. Then this is the output file we are creating. QIEM is always giving us the output in a QZA format, QIEM to artifact. Then
Okay.
input format, this is an option because we are using a paired and fastQ sequence 33 based version. Okay?
Okay. If we have a
Yeah.
single end file, then we need to change some modification here.
Yes. For the single end, the option will be sample, paired and sequence with a quality. So here it's a single end sequence with a quality. And then another option you have to change is here, this format, single end fastQ manifest. Okay? This link I
Okay.
have given already with you, right? So in this link, every another like alternative option is also given, like what is like if you have a single end data and paired end data. Okay.
Okay. Mhm. Thank you.
Yeah.
Hi Dhanushri, I'm facing some problem. Do you have access to WhatsApp? I can send a screenshot.
Yeah, you can send the screenshot in the WhatsApp group.
Okay. Yeah.
I've shared it yesterday, sir.
I've sent it to you.
Yeah, I will. Yeah, this is the link for the installation. Please copy it somewhere so that maybe if you missed it today, it will saved inside your system. Okay. Okay, I will check. Is a not column. Uh, can you share your screen, ma'am, if possible? Can you show me your metadata file? You have some problem in your metadata file. It is saying that forward column is not there.
Yeah, actually, I'm working on different systems. So, I mean, maybe I'll
Hmm.
share the screenshot again.
Sure.
Is it
Yeah,
okay?
please send me the screenshot of your metadata.
Metadata.
Right.
Okay.
So, in which format you saved your metadata file?
Uh, I have saved it in yesterday you told like that one. What was
Hmm.
that? Tab. Uh,
Okay.
yeah, so I have that file as well in the same folder.
Forward option is
Yeah,
not
it's
a
here.
column in your metadata.
What?
See. The thing is, whatever the command I have given, the metadata M is small. But whatever you have given file name, metadata M is capital. So just change the name in the command. Keep
Okay,
just
okay, okay.
yeah, that's a error. Just
Okay, thank you.
yeah. This command will take time. Are you like the error is clear? Like what is the mistake?
I got it.
Oh.
It was different file name, that's why.
Hmm.
Thank you.
Yeah.
So again, I'm getting error because I'm not using absolute path. I'm just accessing it from my Linux. So
Hmm.
that's
It
also all
means
right? Like I'm not giving from like uh how do you do yet you did, right? That way I didn't do. So I'm just accessing folders from Linux directly.
yeah, that's fine. Like from wherever you are accessing, you have to
Yeah.
give the path directly from there, right? You have to open the terminal from the metagenomics folder, correct?
Yeah, I'm from terminal, I'm using it. Like I'm not giving it from the folder. I'm not giving it path from there. That's also all right, right? I mean, I'll
Sorry,
send
I
you a
didn't get
screenshot.
you what you want to say.
Okay. I'll share the screenshot. So maybe you
Okay.
can see. Yeah, I have shared it.
Mm-hmm. What is the problem now? Metadata not used. But I think you are giving the correct path, right?
Yeah, it's correct, but I don't know why it's not like working.
Can you just normally open this metadata.txt in the notepad?
Yeah, that's what I've shared you one screenshot of that as well.
Okay, okay.
Yeah.
But I
Just
think that's fine. Means like
I don't know then why it's not working. Do if I like I have two files. That's why it's not working or something.
two files means like inside the raw
Like
data and
no. Inside like so I have to keep this file in raw data, metadata one.
no metadata you have to put it into the
This folder only.
metagenomics
Right.
folder only.
Yeah.
Yeah. Metadata parent is not a column in a metadata. If you can connect from your system where you're running, I can connect and I can check because I can try some solutions.
Okay. So you want me to show my screen?
Yeah.
Okay. I'll log out and I'll log in again.
Mm-hmm. Um, okay. Are you there, ma'am? I got the error.
I'm saying, hello, ma'am. It's done from my side. I imported the files and output is a QZA.
Yes, yes. Just a minute. Let her
No
join.
problem. I'm just,
Yeah, yeah.
yeah, I'm just updating.
Yeah, yes, yes, yes. My in my system is also done. So actually, she's given. I think she was given the wrong headers. It's forward absolute file path. Wait, we'll just wait for us. Hello, ma'am. Shiva, ma'am.
Yeah.
Actually, the
I'll
error
show.
is in a header. 1 minute. So the
Okay.
header is forward absolute file path. It is. You have given only the path. Can you check the header
Okay.
once? I can share my
Here.
screen. I will share my screen. Just a minute. I will show you. If you will see on my screen, is it visible to you?
Yeah.
Yeah. So if you will see the header, it's forward absolute file path. But what you have given,
Okay.
just a path. The
Okay.
header is like the same header we have to give. Okay.
Okay. Yeah.
Okay, all right. Please make it correct and run it. So here, if you will see that this QZA file is generated, which is nothing but the, okay, I will delete this extra files basically so that
So after generating QZWave, we can remove the old data as well.
yeah, means like it's just for I'm deleting it for my understanding.
Okay.
Yeah, means like because there are a lot of files, so if it is there, I cannot open it properly. Yeah, I'm just hmm, okay. So here, if you will see that you're having the parent DMX QZA file, which is a QUIM2 artifact. But you know one thing that this QZA file we can't read as it is in a binary format. We can't visualize this. So that is why whenever you are having any QZA file, you have to convert it into the QZV format, which is nothing but the QUIM2 artifact format. Sorry, QUIM2 visualizer format. So that's why here in this, you can see our next command is to generate a summary of the imported data, QUIM DEMUX summarize, then input data we are providing parent DEMUX, and the output we are providing DEMUX.qzv, which is nothing but the visualization file. Copy, and then you have to run it. Yeah, it's done. So how we are going to visualize this file QZV? So basically, there is a one online tool we are having, which is you have to type QUIM to view. Then you just have to open this QUIM to view and drag this. You just have to click here on a drag and drop, and then you just have to select a folder and then select the QZV file and open it. So you can see like it is showing you the summary, like how many demultiplexed sequence count summary we are having, how many minimum number of reads in a forward, median, mean, so that frequency you are getting. Also, you are getting here the graph like forward reads frequency histogram, means how many number of sequences are there and in the number of samples for the forward and reverse. And in the downside, you're getting the per sample sequence count. Like this is what the sample ID, this is what the forward sequence count, and this is the reverse sequence count. So this is what means like our data is properly imported. Now we can process for the further analysis. Then here you are having the interactive quality plot also, which is telling you the quality, summary quality score. Like x-axis is nothing but the sequence base and y-axis is nothing but the quality score, like how the Fred quality is distributed in overall the sample. But that we have already checked in the fast QC, so that's fine. Is it clear?
So what is the use of this quality and the
Quality, it will tell you the quality, like how what is the base quality is distributed in overall the sample. That's what we have discussed already in the fast QC. So this is just given
okay,
the summary of your imported data in the Quine. Okay.
okay,
Hmm.
understood.
But that thing we already know. We just I am
Mhm.
just showing you that how we are getting the summary and all.
Understood.
Yeah. Oh, assembled file. Yes, you can say this is the assembled file now. Okay. Now, once we have this QZB file, then our next step is this. Basically, what I will suggest you today is to run this step, because this step will take more than 1 hour in some system, more than 2 hour in some system, more than half hour, you can say. So it's better that today you generate this output so that I can explain it by tomorrow. Because if I will just, if you are going to run it by tomorrow, um, like our whole session will take in this command only. So what you have to do is today you just have to put this command as it is for running. It will take a lot of time, but you don't have to shut down your system. You don't have to close your terminal. Let it run. Okay. Are you getting my point? This data to quime data to command, you have to put it for running now only and let it run. Even if it taking more than 2 hours, 3 hours in some system, so you just have to wait for it. Just tell me once you put it for the running so that I will explain you the step.
Yes, ma'am, I put it.
What about others? Okay. So if you will see on my screen, so basically this is what a sequence quality control and feature table construction step. Feature table construction means right now, as we have imported the data, so we have to find it out how many features are there, how many organisms are there. So that construction table we are going to generate. So basically, QIEM2 plugins are available for several quality control methods, including Data2, Deblur, and basic quality score based filtering. Means in this tutorial, we are going to use a Data2. Deblur is also given over here. If you want to use, you can check it out later. So basically, these steps they are interchangeable. We can select whatever we want, and result of both of this method will be what? It will be a feature table. Feature table means what? It will give you a frequency QIEM to artifact file, means feature table QZA file, or you can say a frequency QZA file, which contains the count of each unique sequence, because each unique sequence is nothing but what? It will give you the count of OTUs in the database data set. Sorry. Then after another file we are getting over here is the feature data sequence. Means whatever the OTUs we are getting, for that OTUs we are getting the sequence also. Now let's talking about the data2. Data2 actually it is detecting and correcting where we need a possible amplicon sequencing data. It means basically it is going to be remove the noise, and it is going to be remove the chimeric sequence. Chimeric sequence means what? Like two or more biological sequences which are incorrectly joined together. So such kind of noises, it is going to be removed by the data2. So here we have to give two options, two parameters in the command, hyphen hyphen trim left. So if you give hyphen hyphen trim left, let's consider 3. So which is going to be trim off the first m bases of each sequence. Okay. Then so it is going to be trim off the first 3 bases in each sequence. Then hyphen hyphen truncate length n. So what? It is going to truncate the length of each sequence at the position of n. And this allows us a user to remove the low quality regions from the sequence. So this you can decide. For now, I'm going to put every value 0 because I don't want to trim or truncate. But just in case, if you are having a very low quality data, so if you cut some few bases from the first side and at a specific read length, if you will give, maybe there are chances that the quality will improve. Okay. So this is how basically these two options you can give. Now, if I will explain you the command, you can see quim data2 denoise single. This is what a parameter for the denoising. Then here demultiplex the sequence input file we are providing. This is DUMEX QZA which we have generated in a first step. Then this trim left truncate length. For now, I'm going to put 0, 0. Then here it will give you the 3 output files. First output file is for the representative sequence, which is nothing but your OTU sequence in a QZA format. Second file, it will give you the frequency table in a QZA. And the third file, it will give you the denoising statistics, like how many sequences are filtered out, how many we are having right now. So that complete statistics you will be able to get here in this third file. And you can see here also this next command will take more than 10 minutes. This is the slowest step in this tutorial. But right now, as per some system, like maybe if you have a lesser space, your RAM is low or less, or maybe you don't have that much space. So sometimes it will take more than hour also. So that's why I'm saying you just have to run it. Okay.
Ma'am, what is the denoise single here? Means why it is single, not the paired? It's related to and
No, this
like
is a
type
default
of.
option actually. It's not about the single and paired.
Okay.
Okay. Yeah.
Yeah, can you share this link to us?
Sure.
The where we can read about.
Hmm. Hmm. It's already shared, but yeah, this you get. What about the shortcut
Yeah, ma'am.
sequence? Can we run data2? No, no, data2 actually, this is what here it is given. About any, if you want to check the quality and all, we have some other tools for it, right? Because generally, sir, this data2 is designed for the amplicon data. Means for processing the amplicon sequencing such as 16S or 18S, or maybe the AVS, ASV also. And for the, yes, it's a targeted metagenomics we are running right now. Amplicon sequencing, targeted 16S sequencing. Yes, every application is having a different tools and pipeline.
One quick question: if we are running the 18S or ITS, is there will be change till now?
No, pipeline will be same because 18S and ITS it's a targeted metagenomic things only. Data will be changed, but
Huh,
pipeline will
means
be
data
same.
will be changed. Yeah, but all the commands will be remain same till
Yes,
now.
yeah.
Okay. So we are not supposed to give any primer sequence or something anywhere.
No, but yeah, if you have a multiplexed data, sir, then obviously you have to give all those barcodes and all metadata file. But if you
Okay.
have already demultiplexed data, then the same thing. But for the multiplexing also, in this link,
Mhm.
like if commands are given, maybe I will show you tomorrow. I will find it out
Okay.
because there are so many links are there, and then I will show you. Okay?
Okay. Yes, please. So that
Maybe
it's make more
just a minute.
understandable
I'm
for us.
here. Yeah, you can see here. This is what a multiplexed for the multiplexed data it is given. You can check this link. Okay?
Or
You
the
have
same
to
link
give
what
the
you share.
barcode file. No, no, this is the another link I'm sharing. Yeah, this is in a same link, but it just you have to find it out. Yeah, you can check it. This is an importing data link.
Hi, good morning.
So, is there any doubt to you? Because this command will not generate within our session. It will take a time. So, if you
Okay.
have any
So
doubt, you can ask me. Otherwise, you can disconnect.
yeah, please. I'm going to request you that when you have time, just let us know that how we can, if we have a 18S and 16S, like ITS, what needs, what uh, commands needs to be changed, and just give
Nothing.
us some ideas.
Commands
So
is nothing. We don't need to change any option. Pipeline and options will be same, sir.
like any reference database we need to change or likewise, so that
No, means like it's given in the means like reference database. We are not check like for the SR data downloading. You are saying or
yes, yes, yeah, data
no? This is in
downloading.
a SRA database only. The process will same.
Okay,
Yeah.
okay. Like for example, we sometimes use the green genes database, or sometimes there are so many databases to fetch, like match with the reference from our samples
But this
to
SRA
find
is
out
a
the.
publicly available repository, so you will get all of the data there. Most of the data you
And
can.
as yeah, SRA is the data set we are using, but my question is that, for example, green genes database is a reference database from which we
Yes,
are
we are
like.
going to discuss that in upcoming part for the taxonomy.
Okay.
Yes,
Okay. And how long this recording is available for us?
lifetime
Like,
maybe.
okay. Okay. Thank you.
For shotgun, right now we don't have any course, sir, but we are going to launch it very soon.
Do you have
Thank
any
you.
course? for machine learning as well?
Machine learning, yeah, there is some sessions we are having for machine learning course. You can just do the inquiry further.
Okay, thank you. Thank you so much, ma'am.
Yeah, you are.
Have a good night.
Yeah. Good night. Bye.